So just to summarize, we realize we have to take limits at infinity. The first situation we looked at was behavior of polynomials. The second situation that we look at is behavior of rational functions. A rational function is a polynomial divided by a polynomial. Okay. And I gave several examples here. I would say in general, you could look at the leading term of the numerator and the denominator. So I had showed you in a previous example, you multiply by 1 over the highest power in the denominator. Here's another example of this. If I look at this example, the leading term is really 2x squared over x cubed. So this basically behaves like this function. So I multiply top and bottom by highest power in the denominator. I get a 0 as the horizontal asymptote. If you look at this example C over here, the degree of the numerator is 12. The degree of the denominator is 4. So if I just compare the leading terms, this guy kind of looks like x to the 8th. And then we know that x to the 8th kind of looks like this because it's an even power. The coefficient's positive. So when I go off to infinity, you're going to get a positive infinity and positive infinity. Let me show you the thought process behind number 4. Okay. When I look at this, what is the leading term in the numerator? The leading term in the numerator is x cubed. What's the leading term in the denominator? The leading term in the denominator is 3x. Why am I only looking at those leading terms? Because for very large values of x, these lower powers, they don't really affect the graph that much. It's the biggest guy that dominates. This +9, when you zoom out, that +9 doesn't make a big difference, but the leading term 3x makes a big difference. Okay. So if I were to look at this, I would say that this basically looks like 1 over 3x squared. And I understand what that graph looks like. That graph looks something like this. So I suspect it's going to go to positive infinity. Now we can check by calculating a limit. So I take the limit as x goes to infinity, x cubed plus 4x squared plus 3 over 3x divided by 3x plus 9. And I'm going to multiply by 1 over the highest power in the denominator. That's going to be a power of x. So when I do that, my limit becomes x squared plus 4x plus 3. That's the numerator. And the denominator becomes 3 plus 9 over x. We have that situation where the top is constant and the bottom is getting really big. So when I take the limit as x goes to infinity, this guy goes to 0. Okay. So now I hope you can see that as x goes to infinity, it really does behave like this leading term right here. So this limit's going to go to positive infinity. I could do the same thing. I could take the limit as x goes to negative infinity. I'm going to get the same situation. I'm going to get x squared plus 4x plus 3 all over 3 plus 9 over x. This guy is going to still go to 0. And when I plug in infinity, negative infinity, because this is a squared, that's going to make this a that's going to make this go to positive infinity as well. So in both cases, I get positive infinity, which you could tell by comparing the leading terms.